He thought he was gonna leave. Come.
All right, seems like people are arriving. Gray is here, Stucky's here. So I'm gonna move this out the way because it's nowhere to put it. And we need to jump into today's coursework. There we go. It goes away now. All right, now who's coming? It says somebody came, but it didn't let them in. Courtney Dixon's here. Okay, so Miss Archie's absent. Bergardo's absent. Khalees Bailey is absent. Claudia is absent. Angelina Bravo is absent. Michael Brown is absent. Brian Bustamante is absent. Christopher Clark is absent. David Curry is absent. Jamar Davis is absent. Shamar Davis is absent. Courtney Dixon is present. Edward Dooling absent. Chris Flores absent. Oh, Courtney left. Hope he's coming back. John Tez Goss absent. Mr. Gray is present. Janiyah Greer, where's she been at? Okay. Autumn Hall absent. Paris Hall absent. Micaiah Kennard absent. Shay Little absent. Aaliyah Mims absent. Sherrod Perry absent. Hector Sanchez absent. Royale Smith absent. Jalen Stuckey present. India Tyler absent. Martine Valencia absent. Mark Weber absent. Davion Williams absent. And Mia Wilson absent. Okay, so let me give Courtney a little time to come back before I go back and say he's absent. Came in and then left. All right. All right. I didn't know I had that many students. Lord, what have I been doing? They piling them on me. All right, so I think you can see my screen. Yeah, you can. And now I need to see if I can see your cameras. I do. You guys are doing great. All right, so let's jump into the norms today. So we can get into the problem and hopefully get out of here real soon. We got a lot going on in terms of our agenda. So where is this? I gotta come out of this so you can see the norms. I didn't got the norms up yet. Shucks, that's right. My computer, it went down for a second. So let me get to my Google Drive and we're gonna go through the norms real quick. In this time that I'm trying to set up the norms, you could be logging in Edsby and make sure you log into your Google Drive. Your Google Docs, so you're able to like start a Google Drive. A document, so you can start to work with me. And we're going to be doing that shortly. Try to look for today's problem for the 5th. Let's see recent. I had to close all the windows earlier. I had it open already. Okay, there they go. Found them. Grab them from my folders. Put it here. All right. So let's begin with the academic norms. I'm going to have, there's 3 of us in here. Actually, it's 2. All right. So Mr. Stuckey, let me blow this up for you. Would like for you to read the 5 basic norms, all 5 of them.
No one has a right to hurt another person. Education and the class are sacred. We will never behave in a way that would discredit ourselves, our school, or our family. ISO Academy Southwest students always a lady or gentleman. We take pride in EXO Academy of Southwest.
Great job, Stuckey. Next person up is going to be Mr. Gray. I need you to read the 5 academic norms. Can you see them?
Respect the opinions of others. Respect the culture of the classroom. We are attentive to participate. We have high expectations of ourselves, our peers, and our teachers. We are here to focus on preparing ourselves for post-secondary endeavor.
Thank you, sir. That's awesome. That's awesome. All right. So we're going to jump into today's problem. And do understand there's a lot of stuff we got to do because, one, we got to create a simulation of what's happening with electricity. But in another situation, we also have to do the calculations, right? So let's jump into it so it's not belabored and we don't take all day. It's the last period today. pretty sure everybody's getting that burnout sensation. So let's try to power through this as quickly as we can so we have a very enjoyable evening. This assignment, of course, will be due at 8 p.m. tonight. Okay, so this is the Bitmoji class and everything, and we're coming close to doing that because we're in what, 5th week now. And what we're going to end up doing is every student is going to have to create a classroom like I've done here. If you can see my little class, this is the robotics slide. And all I did, I mean, all that was done with this, I said, I keep doing that. No, I don't want to share it. I want to present it. Okay. Keep clicking on the wrong button. So that's me, my little Bitmoji. In the future, you might want to develop your own. And what we're going to do is we're going to take at the end of the quarter, this will be your final project. You're going to take your best scored presentations, right? So all the Google Docs you've made, you're going to take the best ones. And if you're not sure what they are, they'll be graded. And I should everything updated by tomorrow. But what's going to happen is you're going to take those and you're going to put them into this presentation. And eventually, once we get everything set up, your Bitmoji, your slides, you're going to explain each subject you've went through. So start thinking about that. And, this is just kind of a rough analysis or rough draft of what I've done. I actually had Miss Lane help me out with this. Okay, so keep that in the back of your mind. It's coming up. You have to take your best papers and put them into a project that you have to showcase. And hopefully I can showcase a lot of these to staff and townhouse. All right, so that's talking about finals, right? Because we didn't have time to really have finals. Let's try to get everybody caught up. But now we're about to jump into the assignment. So resize your screen, and you're going to drag a tab over. Hello, Miss Kennard. And I'm going to drag a tag over, and I'm going to resize it. So we're about to get started on getting the actual document generated. So make sure you're logged in to your Gmail account. We go through this every day. And then I'm going to open up a doc. There it goes. And next, you want to make sure you open a blank document. And now what? We got to name the document, right? So let me name it. It's going to be due now. 1 second. I'm trying to move some notebooks around. So I got a few steps I got to get y'all. Now I'm going to parse the steps out to you because I want you guys to also have the simulation, right? And it's a lot to do. So I hope you're paying attention as we go through it. Now, due now is what? Well, it would be today's date, which is the 5th of October, 2020. Next is our header, right? So that'll be my name, for instance, Tyler, but it's your name that you're typing, not Mike Tyler. I'm just giving you an example of how to do this, right? Next is going to be what? Well, we discussed it already, right? So it's got to be the date again, 5th of October, 2020. Period. Well, it's the last period today. It's 5th. And you guys are intro to engineering students. Was intro to engineering with robotics, like the meme says, or not the meme, but my Bitmoji. I'm a little old. I'm calling these things meme. It's a Bitmoji guy there, which is supposed to represent me with my White Sox hat and everything else on. Don't know if you guys know. I'm mostly on the South Side, born and raised, and also I went to school at IIT. Right across the street from IIT is the White Sox. All right. So anyway, enough about that. Title. Who knows for a few points what today's title is? And usually you got to go on Esby and find it. If somebody already has it, they can get 10 points for just telling me what goes in the title today. While you guys are doing that, I'm going to type up these words. You need the words of the day. Well, I say words of the day, but one is the school word of the day. So that's the word of the day. I think students put WOTD sometimes. Is, okay. And if you know that, you could tell me for 5 points. And then the other term or word is classroom. Term of the day is. And what would that be? Well, in this case, it's going to be electric potential energy. That's a definition that you have to find on your own. So these combined make, when you find the definitions of both, an exit slip complete of 25 points. Now, these points are to help boost your prior scores. Okay. All right. So anybody figure out what today's title is? No. All right. So what am I asking you? Well, if you go inside of Edsby, this is the fifth period. No, it's not fifth. That's third period because I'm like the video's already posting. I did that on my prep. All right. Yeah. So usually I start with the townhouse. The drawing's over. For the $100 that's done, and this is the room link. But here it says right here, plates at different potentials. That's the name of the title. So let's get that in there as our title. Plates at different potentials. Okay. All right. So we got a lot of background knowledge we got to fill in, right? But let me grab the Sims because again, I had to restart my computer because it froze. So I lost a lot of tabs that are open. Just bear with me. So just work on getting this done, this much. And don't forget, we got 2 questions we got to put in there. So the first question is the 1S. We're going to do that together in class. And then you also are responsible for the 2A problem, which is the asynchronous problem. There's 1S. Try to go back and get 2A because both are going to be due by 8. You just got to try them both. It's the same procedure. So you shouldn't panic. You just try the same thing I showed you on the problem. Okay, so that's going to be 2A.
Post that in SB.
Yep, it's been in SB. Yeah, it's still in SB. Yeah, you can grab it. So let's go through our agenda real quickly. I usually have us read what was in SB, but I got to start showing you guys the objectives so you know exactly what I be having planned for you and where I'm going with my thoughts when I'm teaching you guys this stuff. All right. So let me present this, and I'm gonna have. Let's see here. Gray, can you read the agenda right next to my cartoon version of myself? I guess. Gray, you there?
Students will be able to analyze the connection between the electric field and the electric potential.
Thank you, sir. Thank you. All right. So usually I'll say class will begin, but I'm gonna change that in a minute to class will resume. We're gonna go through. Let me grab the simulation too, because you guys are gonna need that. So what was today's simulation? You go to FET, and I'll find it for you before I put in the chat for you guys. You gotta get an idea of what you're doing, a visual. Okay. So let's let this load. All right. And then the next step is to actually go to simulations, and we're gonna try physics. You don't have to do all the steps I'm doing, but I'm
Can you
going
put it in the chat?
I am. I knew you was about to say that. So you don't have to do all the steps I'm doing. I'm gonna put the final link in the chat. I'm taking you guys through it so you'll know if you don't have the link how to find it. Okay, so I'm gonna go all the way down, and I think the one we did in third period, which I got to do with you guys are similar classes, is forces and motion. Now I'm going to switch to forces and motion basics because when I did forces and motion, this one took too long, and I think some people couldn't load it. I do know this is an easier load, and it's going to help us with taking snapshots. Some students, they don't know how to do print screens too well. Okay, so let this load, but I'm going to put this in here, and we're going to focus on this one called acceleration. Okay, so let me grab the link. And the goal is to also have a picture in your document. Because pretty soon we're going to be doing reports and having discussions, and it's going to be kind of tough if you're not used to just making a general report. All right, so open that up because I know it might take a little bit of time to load for everybody else, depending upon internet speed. And when you do, open it up by clicking on acceleration, and it turns into this screen here. All right. And you're like, all right, Tyler, what is this? All right, no problem, because we got to hurry up and take a picture of it and do our problem. Now, in our problem, it talks about acceleration. And I think it's, I should put the question in there. We should read the problem, put it in the chat, and I'm going to have Miss Kennard read it. Give me one moment. I haven't heard from her. She's in the class, but I don't see her. Oh, now I see a light bulb. Something was moving over there. So, Miss Kennard, can you read what's in the chat?
I can't see what's in the chat.
You can't? Why not? Can you come to your Google Meet? Do you know how to press the chat button and see it or no? No. She's muted. All right. Greg, can you read what's in the chat, sir?
A uniform electric field is established by connecting the plates of the parallel plate capacitor to a 12-volt battery. If the plates have a separation of 0.75 centimeters, what is the magnitude of the electric field in the capacitor? A charge of 6.27 times 10 minus 6 kilometers moves from the positive plate to the negative plate. Find the change in electric energy of the charge.
Okay, so you got 2 minutes to catch up. I paused for a reason, just so you'll see what I'm doing. Okay, is anybody ready to share out now or no? All right, well, I'll just wait till the timer runs out and then I'll call you one at a time to share your screen. You need to have your snapshot in there. You need to have your stuff typed up. Those are all the parts you need.
Can you post the other stuff in the chat? It's giving me a hard time to copy it in the SB.
You talking about the questions?
Yeah, because I'm on my iPad. I'm not on my computer.
Okay. 1 second. You got the first question or no? It's in the chat, but if you need it again, I can put it again.
Oh, no, I got that. The uniform electric fury, I got that. I just need you to post the other ones in there.
Oh, okay. So 2A, right? It's asynchronous problem. Okay. 1 second, sir. Let me grab that. So this is 2A for homework problem, asynchronous. You can put that in your document and try to tackle it the same way I'm going to show you guys. Once the timer expires. Okay. Okay, at this point, we're going to share out. I'm going to stop presenting. I'm going to need you to share your screens one at a time so I can see how far you've gotten, okay? So let me start with, let's see here, Mr. Stuckey. What do you have so far? Haven't heard from him in a minute.
I'm not done yet.
You're not done yet? What? You still trying to get the document?
I'm almost done. But
You
can somebody else go? I'm almost done.
want me to come back to you? What about you, Greg?
Yeah.
I just lost Kennard. Oh, my goodness.
I'm finna share mine.
Okay, sir. You got the floor.
That's all I got right now.
Okay, not so bad. Not so bad. That's all I was asking. You still got to find a way to grab that image. You probably got to go on a computer, Gray, and grab that snapshot from the simulation. Make sure you put the simulation link in your document so you can find it. And that link is in blue in the chat. It's a hyperlink. So, all right. We're ready to start our problem, I think. I don't know what happened to Miss Kennard. She was just here. 1 second. Okay, I want to make sure I did list her. All right. So let's get started on the problem, right? What are the initial steps? Now I'm gonna put it here on the screen, how it should look, but it's gonna be up to you to actually type it up from the chat. So I'm giving you these notes and we're gonna talk about it slowly. So when it comes to calculations, you guys are now looking like, what? How you do that, Mrs. Tyler? You're gonna slow it down a little bit, all right? So let's keep going. All right, so basically, no, this is the same one I'm in. It's not the right document. 1 second, gentlemen. That is so much better. All right, so initial notes you need are these, and I'm gonna explain it first with the notes, and then we're going to the unknowns and knowns, and then we're gonna talk further about how we would do, the rest, like calculate the steps. So here's what you need to know. Let me blow the screen up some more. After you get your image in, like I've done here, you're going to now include some notes about what the electric field is. So this thing of what is that? And you saw the electric field with these little field lines in your diagram, right? So now let's discuss this. Let me grab this and put it in the chat for you. And you have to format it the same way I'm doing. I'm giving you vital notes right now. I hope you're taking them down. So take a moment, look in the chat, and you'll see that you have to type in delta somewhere. You have to type, what is it, Q, lowercase. But let's go step by step. The connection between the electric field and the electric potential is basically this definition or equation. Electric field is equal to negative change in the electric potential divided by the distance, right? So scrolling down, if we are looking at this in steps, electric field is your volts per meter. Negative, negative, I just brought it down. How do you measure change in electric potential? That's the voltage. That's the battery I told you guys about earlier. Distance is always got to be in meters. And what else we have here? Well, we have another equation to find out how electric field works, but it's mathematical. So to get this delta symbol, if you're trying to type it in, you go to insert, and then what is it, special characters. And then you want to make sure you select math. And I just select math, you just type delta, DELTA, and you get this little delta symbol here. You select that, and it will show just like I've done over here. Okay, so that's where your deltas come from. Now this means change in, so one voltage value to the next, or final minus initial of voltage or potential, electric potential, what we use in batteries.
You putting all this in the chat, right?
It's already in the chat. What do you mean? Did you hear me? It's in the chat. It's been in there.
Yeah, no, I'm saying I got that part, but I'm talking about now. It's not on there.
The stuff you're looking at now is in there. In the chat, bro. Like, go back to, was it 3:06 p.m.? Yeah, I just shared it. You share it again?
Yeah. So you talking about the connection between the electric field and the electric potential, right?
Yes, sir.
Oh, well, I got that now, man.
Okay. I was about to put the next steps, but I just wanted to explain everything. It seemed like you got it. So let's keep going, because we still got to solve the problem, right? So this here you're going to need later on, the change in electric potential, because you have to find the change in electric potential energy, or potential energy, PE. All right. And this is Q for charge. So what does that mean in measurements? Volts, that's your delta V. Joules, that's your potential energy, but change in electric potential energy. All right. And coulombs, that's your Q. So that's your charge. Now that charge you've seen in the diagram we developed, if you did your screenshot, those charges are on each plate. That's why this one's called the separation, or I think it's the connection between electric field and electric potential. It's the two plates in between, right? That's actually the name of the topic, plates at different potential, or potentials, I should say. So, all right, let's keep going. We got more notes we got to plug in, right? Come here. The next thing we need is our known and unknown values. Now, you got to type it up the way I did, and I'm going to explain every step, but make sure you type it the same way. Here's the next set of notes. And how does that look on, how should it look on your screen? Well, I'll show you. Okay. It should look exactly as I've done it. Now I'm going to explain, but while I'm explaining, you should be typing it up. So to get this delta V, I just took it from the notes, and I copied this one, right? And I pasted it here, because that's one of the values we're given in the problem. And thank you. I was waiting for somebody to share, sir. Thank you, Stucky. So can you see my screen now? I'm glad he said something, because I didn't even know it wasn't showing. Okay, so I'm going to slow down for like, give you guys 5 minutes to catch up. You just tell me to go up or down, because that's my fault there. I didn't know the screen wasn't shared. And I don't want to go too fast and you don't know exactly how to format, your
I knew I wasn't tweaking. That's why I'm like, are you sure you put all this stuff in there?
Well, it's in the chat, but Jalen just told me I wasn't sharing my screen, and I thought it was. So I think that was from earlier when we were sharing out our screens, and I forgot to turn it back on. So I was talking about this part, guys. All right. So take a moment. It should look like I have it. And then the same is true for the above, but I'm giving you 5 minutes to catch up. so you'll know exactly what you're working with. That's as far as I've made it. We'll take these 5 minutes to get it all together. It has to be typed the same way so you can follow the notes and take care of the homework problem. You mean this up or some more? Some more? Okay. That's pretty much it. We got the problem up here. So where did you want me to stop at? Okay, you gotta let me know. You ain't saying nothing, Jalen. Is your microphone working? Or you just not in the mood to talk, huh?
I'm just not in the mood to talk, but
Oh, okay.
I didn't get the word of the day and stuff.
Oh, okay, okay. Right here.
Yeah,
All right. So the word of the day, if I remember correctly, was bolster. Right? Said that in Townhouse. If you missed it, you still got to look up the definitions for each and plug those in. Great job on remembering to do that. That's like 25 points people usually just throw away. So 1 minute and 48 seconds, and we're gonna continue. Ooh, Jalen, turn your mic back off. That's why you had it off. Get conversations going. All right, so 1 minute 30 seconds, and we're gonna finish this problem up. You should have your simulation, so you can be successful. I think this problem has 2 parts, so we got a lot to do, y'all. We got a lot to do. All right, so I think he has it. I'm gonna scroll down a little bit. And this is where we left off here. A few more seconds. All right, all right. So I just slowed it down a little bit to be fair because I forgot to share the screen, but I hope you guys got caught up. We got a few more notes to do for what I'm seeing on my screen, and we'll be done with this problem. We'll be wrapping up. So if everything goes well, I predict maybe we'll get close to 10 minutes early leave, maybe. But let's get to the steps you need, right? So this is part A calculated out for you. Okay, this is what you would do, and I'm gonna explain everything, and I'm also putting in chat so you guys can understand what to do. But first, work on typing it up while I explain. Let me actually put it in the chat first. I'll give you time to catch up because I know it takes time to edit this stuff again. Okay, so those are the next steps, right? Your electric field. And the reason it's E, let's go back to this, is because of this equation here. All right, that equation is defined as our electric field. So E is what we're looking for. And if you look at the problem as well, the problem said if the plates have a separation as distance of 0.75 centimeters, what is the magnitude of electric field of the capacitor? Now, I don't know if I explained this or not, but the 0.75 centimeters cannot be used as centimeters. We have to remember only use meters. If you look at your definitions or your notes in the middle of the page, that's why I put them in the middle page so you can see what to do. Next, it was negative 12 volts, and that's just where we was taken from the how it was explained. It said the charge coulombs moves from the positive plate to the negative plate. So it's assumed to be negative because of the direction it's going. Just like we saw with the electric field here. All right. So now we have a new situation with this where it's negative, negative, and that's going to actually turn this situation to positive. If you see this here is a negative there because of the equation above, and the battery power was already negative 12 volts. Okay. So negative times negative makes positive. That's why you got positive 12 here. And then you're going to divide it by, remember, we couldn't use centi. So the meters was converted to just 0.75 times 10 raised to the negative 2 because we had to convert it to just meters. That's how I got meters. Next is the same value I got, the charge. It's not really used yet, but it is in part B. So I hope you guys got it. I took the equations from above, I plugged the numbers in, and through Symbolab, it became 12 divided by 0.75 times 10 to the negative 2. Now, you're going to be doing this problem on your own, so I should probably demonstrate how to do that in Symbolab, right? I want you to be able to calculate it correctly. And this is, I'm going to put the link in the chat. It's the easiest one to use to do quick analysis. So let me put that link there, and you could try it out because you're going to have to do the calculations on your own in the asynchronous problem. All right, so what does that look like now? I got to, bring this over so I can recalculate something, right? And I end up with, let's use the fraction, right? And what was it? I said it was 12. It turned negative, negative. I didn't tell you to do all that. Come back here. There we go. And this is, I'm going to put, what is it? It's divided. Yeah, so I'm putting in parentheses and say, hey, divided by, because if you don't put in parentheses, it'll jump out. 0.75 multiplied by 10. And you're going to raise that by clicking on this superscript button. And it's going to be raised to the power of negative 2. I didn't click on the negative 2 here because it's not positive 2. It's a negative 2, right? Make sure I'm still sharing. I don't mess up again. Yep. And come on the outside and I hit enter. And if I hit enter, I get 1600. And to be honest, that's what we got here. So 1600 volts per meter. All right. Sounds fair and cool, but we got a part B still. So I hope everybody's ready. I'm about to post part B next. So let me grab it for you guys. And this is pretty much part B. It's a lot to it. So let's go through it slowly and discuss what's happening here. Okay, so put that here. And what do we have? Et voila. Wow, it looks like a lot of, yeah, you got some correcting to do on that. So let's go through it so you know how to edit it correctly. Let me give you guys 10 minutes to get everything done for the synchronous problem. This is in-class work points. I need you to share your screen to see how much you actually got done, okay? But if I'm giving you all the notes, you really should have like the whole synchronous problem done, and then we can just discuss real quickly grades, where the video is going to be at, and also like how to handle that second problem. This is all due by 8 p.m. So I think you guys see my screen, right? You also see in the chat, it's not exactly the same as what's on the screen that's in the chat. You got to go through and be careful with some things like these. I do want to see in different colors because they go away. Like you see, this is the initial step that came after doing algebra on this equation here. And as we went through, I was able to cancel out the charges. So that's Q multiplied by a Q that's been divided. And what happens is they cross out because Q divided by Q is just 1. Okay. So next, what do? Well, if we're looking at the next step, we just rewrite it where we have delta potential energy or change in potential energy, that's what delta means, is equal to a negative 12 volts. All right. Now there's no negative sign on this equation. So that's going to be multiplied by a positive 6.27 times 10 to the negative 6 coulombs. Volts and coulombs, they combine to make joules. So you're going to cross those out in the next step as well. If you can see what I did there. Let me zoom in some more. If I can't, yeah, 200. So it was like, it's not even all the way up. So now we have what? We have just volts and coulombs is gone. We now end up with joules. We come down to the next step, or iteration, I should say. And it's negative 12 times 6.27 times 10 to the negative 6. Let's put that in the calculator real quick so you can see how that works. I want you to test these tools out so it's not catching you off guard when we're not synchronous anymore and we're asynchronous, right? So how do I calculate that? Well, it's because we can use parentheses because it's a negative, right? And then 2. Did I put a Z there? I didn't want to put no Z there. I said parentheses. There we go. Then it's negative 12, right? Come outside of parentheses, pressing the arrow key, multiply by parentheses again, because this is a long number, 6.27, and it's multiplied by 10 raised to, again, click on that subscript button up here. And what is it raised to? It was negative 6, right? Yep. So that's negative 6. Hit enter, and it gives me what? It's the same thing we found earlier. Yep. So that's in essence, that's all we're doing, right? That's the last step. And you just bold your answers and make sure you have it correctly done. Okay. So I'm gonna give you 10 minutes to catch up with everything. I'll blow the screen up. And this is to really, really get a lot typed up so we can discuss this problem here, which is very similar. I want to see y'all at least get to setting up your known and unknowns and then go. So I think you just need a little push to get started. But we need 10 minutes because it's 3:24 to complete as much as I've done with the edits now. And don't forget about your snapshot. Okay, if you need that link again to the simulation, let me know. Even take this time to fill out what you think bolster means, definition, and also the technical definition of electric potential energy. All right, 10 minutes, guys. Okay, we're gonna be doing share outs in a moment, everybody. You two gentlemen, the fearless two. And all you do is share your screen. You should have as much as I have, like the whole problem, the whole synchronous problem, which you will be practicing on your own with the asynchronous problem. But bolster, what is that word? Put the definition in there. Jalen, you ready to go? All right, let me stop sharing. You making this quick and easy. All right.
It's only about two of us in here.
Yeah, you're right, Greg. You're right. Okay, so let's see what you got, man. You got the floor. Okay, Jalen. Okay, I see something. All right, where's the steps at? What happened? Oh, you put. Oh, okay. So only. Goodness gracious. So Jalen, that goes all before 2A. So can you just cut 2A and put it at the bottom of your document? Otherwise, you did pretty good, man. Now, were you able to get your image? Okay. Okay, okay. Good, good, good. So you got your snapshot, but you need the one that's for so that's acceleration, but Jalen, that's for physics. That's not for this class. So that was my error. Go back and take a snapshot of this here. Let me find it so I can show you. You stop sharing, but you need this one. Pretty good though. But all those steps and all those notes, they go right after 1S, not after 2A. Because when you get your problems right. And let me share real quick so you can see what I'm doing. You have this situation here, right? And what does that look like? That looks like you got the battery pulled down to negative potential, and it's got the E field pointing up instead of coming down. So this is what I wanted you to see to take a snapshot. So to make a snapshot, it's like you did with the other one, but take this one once you recreate it, and then put it into your Google Doc. So you got till 8 to do that, but you're pretty much free to go, dude. You did great. All right, so make sure you have that in there, this image. You want the link to it again? Would that help?
My turn.
All
Yeah.
right. I'm gonna put the link in the chat, and Gray, I'm about to share the floor with you. Or stop. He gonna share his. Okay, you on the phone? Bro? Hold on, let me
Yeah,
stop.
I'm on my iPad. I got everything besides the picture.
Besides a picture. Okay, so you need that next. Okay, the link to the simulation, it should be there. I think I put it in there, right? There it goes. Okay, so that's the link you would use. And you guys just need to put that in there so you can finish up everything. You need that image. If you're having trouble submitting the image, take a screenshot and send the image to me via Edsby, and I'll count it as score. But you need both, whether it's in the document or sent separately. Last thing I wanted to talk about was where to find today's video, library, library, library. I keep telling you guys, okay, don't forget. And another thing was we got progress reports coming out on Thursday, I think. So try your all this. Yeah, this quarter ended, huh, Gray? So try your best all this week to get that stuff in because it's about to go out. So try to get some of that work done. Seriously. I think that's it. Don't forget about the asynchronous problem. And yep, I promise 5 minutes. You guys are free to go. We end at 3:40. We're done, gentlemen. Now I could go back if you need me to go over this because I'm gonna be here until about 3:38 getting the video ready. But is there anything you need me to scroll up or you might have missed or now's the time to speak?
I'm good.
Yeah.
Okay. Do know the problem is not hard, guys. It's the same as a problem that's just done. You just got to use the notes to do it. Okay.
Yep.
All right. 8 p.m., gentlemen. You're free to go if you have no more questions, gentlemen.